My name is Matthew Powelson, and today I'm going to be doing a quick demo on the iRobot crates that we have here at the Intelligent Vehicle Development Cluster here at Tennessee Tech. This is a pretty inexpensive mobile robot platform that we have here. It's about $220, and we have several of these that are available for students. So what does your $220 get you might ask? Well, it gets you this full package. It gets you the crate itself, a rechargeable battery, a serial cable, and a charger. But what you're interested in, I'm sure, is what the crate can do. So it's a differential steer robot. It means you turn it by varying the wheel speeds. It also has several sensors on board. It's got two bump sensors on the front, right bump, left bump, and you can combine the two to get center bump. It's got wheel drop sensors, so you can detect left wheel drop, right wheel drop, and the caster drop. It's got 4 different, what they call cliff sensors on the front. Those are just downward-facing IR sensors that detect changes in reflectivity of the surface you're driving on. So you can use that to, say, detect the edge of the cliff before you fall off. Or you can use it to detect things like black lines, white lines, whether you're on carpet or hardwood, something like that. So that's a pretty useful sensor. You can detect the buttons on top. If you're controlling it via serial commands, you can anyway. And you can control the speed. Now this thing does have encoders on it, but you can't actually detect the encoder data directly. What you can do is give it a wheel velocity, and it will try to maintain that wheel velocity. So that's something you should keep in mind as well. So how do you control this thing? Well, it's got 2 serial connections on the side, and the way you control it is via serial opcode. So you'll send a specific number to the crate via serial commands, and it will execute whatever command corresponds to that opcode. So that opcode might be to drive at a certain velocity. It might be to send back sensor data. It might be to perform some operation to play a beep or something like that. All those will be found in the Open Interface Manual, which looks like this in a PDF version online. Alternatively, you don't really have to read that if you're going to be using something like an Arduino or MATLAB. There are some manuals that wrap all those opcodes into functions in MATLAB or Arduino C. So it is important to know how the opcodes work, but it's not necessarily something you have to memorize unless you're just going to be controlling it via a straight serial terminal. Okay, so here we have the crate connected to an Arduino Mega that is going to provide the serial commands to it. So the Arduino actually has 2 different serial ports, one of which is communicating with the computer via this USB, and the other one's communicating with the crate via this homemade cable here. So this shield is actually taking the pinout from the crate, which is a DB25 parallel port connector, and it's rearranging everything and putting it in a form that makes it convenient for the Arduino. We're connecting it to the serial 1 is going to the crate, and the serial 0 is going to the computer. Also, the Arduino is equipped with a regulator, so we can actually draw power from the crate, and this external regulator regulates it down to something the Arduino can handle. So I can actually unplug the USB, and the crate will power the Arduino, and it will be fine like that. Okay, so here's a quick demo with the Arduino controlling the iRobot crate. As you can see, I'm going to unplug the USB cable, and the only thing controlling the crate right now is the Arduino. So it's powered on, and I previously loaded a sketch. This is an example sketch called Roomba Drive Test that we've included in the Roomba library that you can download. It's an example we added for your convenience. So anyway, I just reset the Arduino, and it's going to drive, it's going to turn left, and it's going to turn right. Now, that might not be very impressive, granted, but as you can imagine, if you can control the movements of this thing, you're halfway there to being able to do some pretty neat stuff. So now all we need to do is figure out how to get the sensor data from the crate into the Arduino and use that logic to control the movements. We have an example where we actually did pull in the sensor data from the crate and put it in the Arduino. So this example is pretty simple. All it does is drive forward until it hits an object, and then it's going to back up a little bit. So here we go. Okay, so you can see what happened. The Arduino gave the command to the crate to drive forward. It did so until it received a bump sensor indicator, and then it is told to reverse and then stop. So again, this is a pretty simple example, but it demonstrates a proof of concept that you can use the onboard sensors to control the movement of the Create, and then the rest would be up to you, the programmer. So that's all I have for this demo. I did bring out a couple of different sensors that you might be able to incorporate in some of your Create creations. Here's an IMU that you've seen previously in other videos. You can use that to detect motion. And we also have lots of these infrared rangers here that you could use to detect walls, detect lines on the floor, anything like that. And here's an example right here, actually, of just that. We have an IR sensor array and a big contraption mounted on top of a Create. So the Creates can carry a payload if your design requires that. And here we have a haptic paddle. This is a force feedback device that you'll see in a couple of videos from now that you could use for human interaction with a robot. So there's lots of possibilities there. It's really up to you. So the Intelligent Vehicle Development Cluster is housed in Brown 124. Come by, check something out, and see what you can create.